So we're going to use our baking robot in this example again for multivariable expressions. We loved our robot so much, and I think I might use him for the next few videos as well. So let's say our robot, let's call him Alfred the robot. So Alfred is just baked a cake, and now Alfred needs to figure out how to get from the kitchen, say the kitchen counter, to the dining room table. So he's got big cake. Draw him holding this thing. So Alfred is holding this cake, and Alfred has the task as a robot to take his cake and go all the way to the dining room table. Okay, so Alfred already knows, using his sensors, he's got sensors all over his body that can detect things, and he knows that this distance right here is exactly 11.4 feet away. But the way that Alfred moves, it's not in uniform steps. And what I mean by that is that he can take 3 different kinds of steps. He can take small steps, can take medium-sized steps, and he can take large-sized steps. And the reason why Alfred takes different sizes steps is for efficiency. So you can imagine if something's really far away, it wouldn't be efficient to take tiny steps to get there. So he would take big steps at first. But when he gets really close, maybe a big step is too much. He needs to make those increments smaller so he can get exactly where he needs to be. Okay, so let's say that a small step equals 0.2 feet. Which is also 2.4 inches. And a medium-sized step is going to be 1 foot. And a large step for Alfred is 2 feet. These are the distances that he covers with each of those steps. Okay, so now what Alfred is trying to do, or what he's going to do really fast, because he does this all the time, is calculate what combination of large, medium, and small steps he needs to get from where he is with his cake to the table in the most efficient way possible. Make that table stand out a little more. So he is going to figure this out, and what he comes up with is a multivariable expression. And to simplify things, let's say that instead of small, medium, and large, we call these A, B, and C, just to simplify our expression. And Alfred has figured out that his final expression is going to be 2 A's, so 2 of the small steps, plus 1 B, and we're just going to leave off the 1 there because it's just one of them. And then we're going to do 5 large steps. Our multivariable expression turns out to equal 11.4 feet. Let's break this down step by step. 2 times A. And this equals, in our case, A is the small step. A equals 0.2. 2 times 0.2 is going to be 0.4. Plus B, our B was the medium step, which is 1 foot. So we'll say plus 1. And then finally 5C. Well, C is 2 feet there. So we're going to say plus 5 times 2. Okay, 5 times 2 is 10. And so if we add all of these together, we've got 0.4 plus 1, that's 1.4, plus 10, that's 11.4 feet. And so our robot has successfully figured out how many steps of each size to take in order to get from where he is to that table in the most efficient way. Good job, robot.